All right, so let's get going here. We have Unit 6, Lesson 2. We've split up the Pythagorean Theorem into two different lessons. This is going to be solving for a missing leg. So we're still doing the Pythagorean Theorem. What is the Pythagorean Theorem? It is a squared plus b squared equals c squared. This is a leg and a hypotenuse. So that's what A, B, and C are to form the Pythagorean theorem. So you have to find what the hypotenuse is first every time. So that's why we are going to continue to look at this triangle from page 411 in your textbook, volume 2. And we still have a right triangle. Let's go through the process of what we do when we see this right triangle. We go through and we label it and mark it up appropriately. So we take our red pencil or pen and we mark that vertex as a right angle. Remember, this is a capital C, and we drag across to little c. This is the hypotenuse. Then we have capital A, we drag across, that's lowercase a, that's a leg. And here B, we drag across for lowercase b, and that's also a leg. So this time you're going to be given a leg and the hypotenuse. Let's go back to our values. Let's remember that we had a value here when we measured it of 11 centimeters. And let's say I had leg A. That would be 6.5 centimeters. So if I didn't know this third leg, then I could plug in for A and C, and I could solve it for B. Let's look what that looks like. I have the Pythagorean theorem is A squared plus B squared equals C squared. So I don't know, this is my unknown thing. But I know A and I know C. So now I can put in there 6.5 squared plus B squared equals C squared is 11 squared. You might not have a calculator, so 6.5 squared could be a pretty hard number. You could, if you wanted to, change 6.5 squared. You could change that to 13 halves. That's 6.5 squared. And then you can, then it'd be easier to do 13 squared over 2 squared. It's 169 over 4. If you didn't have a calculator. So I have a calculator. I'm going to do 6.5 squared. Gives me 42.25. Plus B squared equals 121. This is, now it's an extra step compared to the other thing that we did. I need to isolate B squared, but the 42.25 is on the left side. If I want to get rid of it on the left, I have to subtract it away. It's additive inverses. I have to subtract it on the right side too, because whatever I do to the left, I have to do to the right. So if I'm going to subtract 42.25 to both sides, that's gone. I'm left with B squared equals, I need to use a calculator, subtract 121. It's 78.75. So in order to find what B is, I got to take the square root of B squared 78.75. And I'm going to need to use a calculator for sure. If not, I could calculate, it's between the square root of 64 and square root of 81. It's closer to the square root of 81. So this is going to be somewhere around 8.8 or 8.9. But to find the exact answer, square root 78.75. And I get 8.87 or 8.9. We measured it in a lesson 1, and it was 9, so that's pretty reasonable because the marks on the ruler are very small. Page 2. If you need to capture that, take a second to capture it. Good job, Michaela. Thank you. So again, your book, it gives you the Pythagorean theorem. It also gives you little a, little b, and little c. What's missing here? You need to label your vertices diagonally across from those side lengths. So this is capital C, where you see the red mark. This is capital A, and that's capital B. So we're applying the Pythagorean theorem, and we're also still doing pretty much the same to-do list. A and B haven't changed at all. So I'm going to label them the legs and the hypotenuse. I have a leg, and the hypotenuse. And I've got to label the vertices, and I start with the letter C because it's at the 90-degree angle. Then it doesn't matter what I call A and B, except for the fact that they've given you the letter B here, so we need to label this vertex over here capital B. That makes that capital A. So now I know little a, I know little b. I don't know little b, but I do know that this is C. So we plug in for what we know. 8 squared plus b squared equals, and I know c squared now, 24 squared. So then I got to square 8, that's 64. 24 squared is 576. Again, I need to subtract. To isolate b squared, I'm going to have to subtract 64. 576 minus 64 is equal to 512, and that's your b squared. Now you could take an extra turn and rewrite this with the square root, but we're going to be taking the square root. So let's do it at that step. We'll write that thing is also called a radical, the square root symbol. So I'm going to put a radical, b squared radical 512. So I'm going to use my calculator. I'm going to hit the square root button on this particular calculator. Square root 512, and I get 22.6. Typically, we're going to the nearest tenth here. So now it says check. This is applying the converse of the Pythagorean theorem. Now we're gonna check it by putting in all the values. So we're gonna do 8 squared plus b squared. Now remember that we evaluated it and we rounded. So let's put the original amount in there. Okay, we know that b is the square root of 512 and squared. You could have just put, we know that b squared equals 512. You could have just put this value in here. You're going to get the same thing. And c is 24 squared. So I have 64 and 512 equals 576. And I'm asking myself if I did my calculations correctly. And you see that you get 576 does equal 576, so it checks. So we still are doing identifying the parts, labeling vertices, substituting the values. Now it says in lesson 2 that's a leg and a hypotenuse, and then we still solved it under PEMDAS. Except I took out the plus button and I entered in a minus subtracting button because you're using x squared, you're subtracting, and then you're taking square root. Okay, go ahead and capture that if you need it. A couple more examples. Same process, and I've put check over here in case you get to that. So let's do another simple case. Again, find the right angle. That's your capital C. There's little c. There's B, so we're going to have to call this point right here. Because remember, we go diagonal. This is capital B. So that's capital A. So 3 is equal to A. Now I have my Pythagorean theorem. I know A is 3. I don't know B. It's a big question mark. That's 9 plus B squared equals, well, I know C. I'm sorry, that's 8. 8 times 8 is 64. What do I do next here to get to isolate the B squared? How am I going to get B squared isolated? That's right. I'm going to subtract 9 from both sides. Good job. 64 minus 9. 64 minus 9 is 55. So then I could just take the square root. To find B. You should be mentally thinking, okay, well, the square root of 49 is 7. The square root of 64 is 8. So this number has to be closer to the 7 than to 8. It's probably about 7.3. Radical 55, 7.4. And they have their units up here in miles. And then you can check it. Again, A squared is 3. We know the value of B squared is 55. So let's, instead of the entire B squared, we can just replace with 55. And then C squared is 8 squared. That's 9 plus 55 equals 64. 64 equals 64. We were checking by the converse of the Pythagorean theorem. If you need to capture that, go ahead and screen capture that now. And then we have our last problem here. So if this is 20 and that's 17, this side is obviously shorter, is the shortest leg. What's a good guesstimation of what you think A is going to be right here? Type it in the chat as I label this triangle with the proper letters, capital C. What do you think a good guesstimation of A would be? This is capital A, capital B. So we have our value of B is here, and the value of C is here. What's a good guess? Looks like this side is 20, 17. What do you think a good guess for this side would be? Yeah, that's a good guess. We have some guesses at 18. This side is definitely looks a lot shorter than this leg. Usually we call A the shortest leg, so it should be a little bit less than 17. Right, the hypotenuse is 20. Let's calculate it. 17 squared is 289. So I just subtract 289. That's 111 is A squared, so A equals the square root of 111. Which is just over between 10 and 11 somewhere. Square root of 111 is 10.5. So some good guesses there. Thank you for the two that really got super close. If we could split your guesstimate, we would have hit it right on the number. Okay, so that's the end of lesson 2.